very good morning, ladies and gentlemen. We're starting slightly ahead of time. My father used to say, if you can't manage your time, you can't manage anything. So a very good morning and a welcome to this gathering, which is hosted by the Royal Academy of Engineering, supported by BAE Systems, and we thank them for that. Our topic this morning is engineering gearing UK growth. When I think about why we want growth, I think about improving the quality of our lives, addressing society's challenges, building social cohesion, strengthening our economy, and critically, creating the education and training that give our young people real opportunity. But we have a lot of competition out there. The UK is an engineering nation to our core. Our great companies have continued to thrive, sometimes despite apparent lack of interest from policymakers. That is, I believe, now slowly showing signs of change, and that would be very welcome. And policymakers across the spectrum of politics recognise how engineering and manufacturing underpin a healthy economy. As professional engineers, we have the skills and the ability to tackle the grandest of challenges and find out solutions that work. Whether in research, technology, business or policy, engineers, I believe, are equipped to analyse problems, synthesise solutions, manage projects that create the right outcomes and turn those experiences into new opportunities. The scale of growth we now need as a nation, the size of the global challenges we face, cry out for a much more unified approach between government, our universities and industry. And that is something we will want to explore today. As one of the leading economies, we have a massive challenge to remain competitive on the global stage. The new powerhouse nations, especially China, are already transforming their ambitions from cheap mass contract production to their own high-tech, high-value engineering design and production. My view is that the only way we can tackle that challenge is by taking our competitors on at what is our game, namely by focusing even harder on our own long-standing comparative advantage, engineering innovation. As many of you know, the Academy manages an engineering research programme engaging some 135 research fellows in UK universities. The programme supports research of deep strategic interest to business and industry. This and many other areas of research and development are the seed corn that creates brand new businesses and the jobs we need. So investment in research continues to be a great advantage for the UK. But in financially straitened times, we must be realistic about what we can afford and what constitutes, above all, good value for money. And at the Academy, we believe that given difficult choices, more investment should be targeted on areas of research which can deliver tangible benefits for our economy. In addition, we need to find ways of translating more of the fruits of research into commercial applications. The reality is that the private sector itself cannot create all of the growth initiatives we need, but it must lever off strong relationships with the university sector and its unique research capabilities. Such collaboration is critical in developing innovative products and creating new technology-led services. Now, right at this moment in time, government has a critical leadership role that needs to be more than just cutting the overheads. Important as that is, To achieve our economic ambitions, we will need to have a clearer industrial strategy, a framework to guide and enable UK PLC. Politicians and commentators have become more comfortable over the years with using the term UK PLC, but equally uncomfortable about being accused of picking winners. But if you're running a PLC, you do have to pick winning strategies, you select winning people, and you search for winning products all of the time. And this framework needs to set out a vision, I suggest, to which businesses our country should major in over the next 20 years, and set out the likely shape of our industrial landscape over that period. Only when you have such a framework and vision can it really create the pull that defines the educational and skill needs, the applied research needs, and the supportive, coherent government policies that are required across departments. That is the leadership I believe we need from government, a vision for a high-tech future for the UK and a roadmap to help us coherently get there. As well as holding this meeting today, the Academy is publishing the results of a study on capturing value from industrial systems, which was chaired by Dr. Steve Garwood from Rolls-Royce, who's with us this morning. And our study calls for a more integrated approach to the UK's industrial systems in order to extract the maximum value from our supply chains. And copies of this report are available for you to take away from this event. In the Academy, a key aim is to grow the nation's engineering capacity by promoting engineering as a desirable and exciting career for young people. This is very much teamwork in partnerships with the professional engineering community, with initiatives such as Tomorrow's Engineers School Programme, the Big Science and Engineering Big Bang Science and Engineering Fair, which this year is set, I believe, to bring in more than 40,000 young people through the doors in Birmingham. And now, too, we have the Queen Elizabeth Prize for Engineering, which was launched at the end of last year by the three main party political leaders, not something you see them very often aligned on. And the journey to find the £1 million prize winner will allow us as the Academy, as we manage this challenge across the globe, to promote the sheer excitement of engineering to a wide range of young people across the world, and particularly our own country. Once we have motivated our young people toward engineering, providing them with the right engineering education is a major challenge. The Academy is working with the profession, government, business, and educational institutions to influence the shape of education and skills policy at every level. And our aim is for the UK to benefit from the right number of well-taught and developed young engineers, and for young people to experience a great, fulfilling, and meaningful career. Now it is time for some political perspective. We had hoped that the Minister for Universities and Science, David Willits, would be able to join us, but unfortunately has been called away to attend an urgent cabinet discussion. I'd love to know what that's about. But we are delighted to welcome Shi Unwara, MP, who's the Shadow Minister for Innovation and Science. And I want to thank you very much, Shi, for coming to speak to us at such short notice. Now, only an engineer could respond like that. And she has a degree in electrical engineering and made a career in telecommunications before entering Parliament. I wish they all did that. And where she has very effectively championed the industrial, science, engineering, and business agenda. And I give you, Shi, a very warm welcome to this platform.
Thank you very much, Sir John. Thank you for inviting me to step into David Willett's shoes for a little while, at least, in advance of a longer transition. I'm sure you can imagine that going from being an engineer to being a politician has many surreal moments. And one of the first was during the 2010 campaign, so my first campaign. And I remember seeing it was Lord Mandelson, Kenneth Clarke and Jeremy Paxman sitting on Newsnight, all sagely agreeing that we needed more engineering in the UK and we needed more engineering in our economy. And that was a moment when I realised that I was going from a profession whose status was on the rise to a profession whose status was at the lowest point of any profession probably in the country. Thankfully, since then, the status of politicians has recovered somewhat. But I do think that, as Sir John indicated, we are at a moment, a very important moment, where we are beginning as a country, as UK PLC, to recognise the role that engineering, manufacturing, science plays, and probably more importantly, should play in an economy. I think that policymakers across the spectrum agree on the importance of engineering and manufacturing to the UK economy. And so we agree on the destination. There is still some disagreement as to the best way to get there and who should be doing the driving. The government is, I think, starting to put together, or to envisage rather, putting together some kind of industrial policy, but it's embarrassed about that, I think, so it's best not to call it an industrial policy. Let's think of another brand for it. And I would like to take the opportunity here today to outline how I see the importance of engineering and innovation in building a new economy based on responsible capitalism, and also what we think the government's role is in that process. Now, it's not just because I'm Shadow Minister for Innovation that I say this, but innovation is a key part of the history of the human race. The human race has always progressed through innovation, from sharpened stones to mobile phones. We have progressed by inventing, innovating in order to survive, to live longer, to live better. And as Sir John touched upon, without ongoing innovation, Britain's productivity, compared with other countries in the world, will drop. And unless we have new sectors which innovate, take up the slack in terms of production and in terms of jobs, our competitiveness drops and our living standards fall as well. So that's why it has to be our priority as a country, and speaking as a politician, to build an economy which is more productive, which is more resilient, which is a broader base. We've seen the consequences of focusing too much on one sector of the economy. And critically, an economy which has fairness at its heart and which delivers for everyone, not just for those at the top, but for everyone in our society. And that's what we call a new innovation economy, which supports value creation, not value destruction. Now, it's not government's role to organise and fund innovation primarily. I agree with Sir John that we need to take an active role, and I'll talk about how. But I think it's clear that when governments try to direct innovation, we're not very good at it. People don't have great ideas because governments tell you to. And when the political cycle is very much out of sync with the innovation cycle, so what we might say we need today may be political old hat by the time it's invented. But there are many non-governmental incentives to innovate. And I'm sure many of you are familiar with The Innovator's Dilemma by Christensen, which charts how both continual and disruptive innovation play such an essential part in the rise and fall of billion-dollar markets. But what is also clear is that the market itself cannot do everything. And that applies particularly to markets which don't exist yet. in some ways the most important markets, the markets of the future. And so we do believe that to keep the UK competitive globally, government, an active government, has to use the right levers. You know, as an engineer, I like the metaphor of the lever to support innovation and productive businesses. And that's about framing the rules of the game so that the businesses which are the most productive are also the businesses which are the most profitable. And our competitor countries, Germany, the US, China, they know this already. They do it. They have strong industrial policies, whatever they may call them. So, for example, Germany and the US both recognize the inherent market failure in the supply of credit and equity to small businesses, something which is very topical right now. And they use state guarantees to catalyse access to finance for small businesses on a much broader scale than anything we've ever done in the UK. So an active government has a number of levers at their disposal. We have held a number of roundtables, one with the Royal Academy of Engineering, one with the IET, in fact, in order to identify what levers it is legitimate for a government to use. And we've identified 4 levers, and I'll just go through them quickly. Firstly, governments need to play an active role in ensuring competitive markets. So, for example, creating institutions to coordinate and support innovation by helping small companies. That reduces the impacts of vested interests in markets and enables and supports growth. Government also has a key role clearly in skills, as Sir John talked about, and in infrastructure. Small nascent markets, the players don't have the resources or often the time to build the essential infrastructure, such as, for example, the testing facility for wind turbines, which was built at Blyth in the northeast. And finally, of course, there is finance. Another example, the government is the biggest purchaser in the UK. We should be leveraging that private sector to leverage private sector investment in green technologies. So those are 4 sort of key areas where government can and should support innovation. But whilst government has a critical role in supporting innovation, setting the framework, as Sir John put it, it is for industry and broader society to play an active role as well. Now, I worked in France as a software engineer, and it was my first time working abroad. I was astonished by the high status in which engineers were held there. The highest compliment in France then was to be called an engineer, and indeed Napoleon was praised as an engineer rather than as a general or indeed as an emperor. Now, in Germany and Portugal, the title engineer has the same status, or indeed higher, than that of doctor. But in the UK, until recently, an engineer was someone who fixed your boiler. Now, historically in the UK, the upper classes took pride in not having a job. Basically, leisure was the defining characteristic of the gentleman. Today, everyone from the Duke of Cambridge to the school leaver on the most deprived inner city estate is expected to get a job. But I think that that legacy of reverence for genteel idleness lives on today in a distaste for occupations which require you to get your hands dirty. And almost everything involving applied science or engineering is thought to involve a little wear and tear on the hands. But in fact, as a good careers advisor can make clear, science, engineering, and technology are excellent groundings for a wide range of careers. I mean, I find it very useful in politics. The scientific method is a very useful contrast in politics to other methods of policy development. And science graduates are also very valued in the civil service, project management, operations, financial services, accountancy, and all forms of management and logistics. This week is Apprenticeship Week, many on the panel I know are doing fantastic work providing high-quality apprenticeships for young people in giving them the leg up they need to succeed, and I'd like to applaud you for that. We also need to work to address the lack of diversity in engineering, get more engineers with better skills. But as well as those tangible things, policies that we need to achieve, there are more intangible things to be done. Engineers need to bang the drum more for engineering. We don't speak up enough. As engineers, I think we believe that our work should speak for itself. I'm afraid that just isn't the case anymore in today's environment. For example, as Sir John suggested, in Parliament, few parliamentarians have an understanding of engineering, any understanding of engineering. And the fact that engineers do not speak with a loud and strong voice enough means that that continues to be the case. But if every engineer, in every company represented here, wrote a long, detailed technical letter to their MP demanding a long, detailed response in reference to engineering issues in that constituency, be assured the level of understanding of engineering amongst MPs would change overnight. But just don't say that I asked you to do that. But whether it's lobbying your local MP or promoting engineering and manufacturing in schools, I would urge all engineers to be more active as engineers. Engineers need to engage more with the world. The world is a sorrier place for the lack of a strong voice of engineering, science and technology. And I truly believe that we cannot moan on about how little engineering is reflected in our culture. Well, actually, we can moan on about that. I mean, I moan on about that all the time. But moaning isn't enough. It's up to us, or rather it's up to you, to make sure government, the civil service and the media understand and respect the importance of engineering. And so that's why it is one of my key objectives as an engineer, but also as Shadow Minister, to ensure that engineering is back where it belongs, at the heart of our economy, our society and our culture. Thank you very much.
Well, thank you very much indeed, Chief, for sharing your thoughts with us. I know they'll help stimulate the discussion later, especially as you've reminded us of the status of Napoleon as an engineer. But we will take your message away of promoting ourselves more vigorously. And that's something that certainly we in the Academy and indeed the profession are increasingly aware of. And now we're going to move to discuss engineering and how to gear UK growth. And we have a very distinguished panel, which I'm going to invite onto the platform now. But before I do so, Chi, I know, needs to get away at 10 to 9. And we do thank you again for coming and being with us at such short notice and giving us such a detailed and inspiring address. Thank you.
So, first of all, thank you for the opportunity to talk this morning. I'm going to say just a few things, as it were, to plant a few signposts for the discussion that we'll have. I firmly believe that the UK has not just a history and a tradition of innovation, but in fact a culture of innovation. The invention of the telegraph, the telephone, the television, steam locomotives, the railway systems, CT scanners, DNA fingerprints, DNA sequencing, X-rays, spectroscopy, cat's eyes for safety on roads. The list is very significant. That's just the tip of an iceberg. You could equally come up with 10 things straight away, and it's part of our culture that we celebrate the great British inventions. In my own sector, in defence and aerospace, then some very significant inventions through the years, arguably the marine chronometer being one of the principal devices that calls us to work out how to measure our progress around the world and build our empire. More recently, radar, the axial flow jet engine. The list is very significant. Within my own company, first operational vertical takeoff and landing aircraft, Concorde, a very significant list. And we are used to those things as part of our cultural reference. Within the company I work in today, we file about 100 patents per year, and our Chairman's Award for Innovation, 4,000 nominations a year, and they are spectacular. I have absolutely no doubt that we can innovate, that we can continue to innovate. The connection between that and having a successful economy, I think, is in the execution. Again, we're all quite familiar with the model that using science and engineering to innovate, to solve complex problems, to generate products and services which you can sell and export, generates wealth and value for the nation, and props up and funds that virtuous circle. We're all quite familiar with that. But somehow that virtuous circle is weakened by various elements, including the way we translate those ideas into the business environment. If the Secretary of State had been here today, or indeed to talk to us about the nature of what the current government is doing, I'm sure he would have pointed out that the BIS analysis most recently concluded says that manufacturing in the UK is in fact the third largest sector, second to business services and the combined wholesale and retail sectors. They would say that 8% of employment comes from manufacturing and that 11% of the GDP, some £140 billion worth of gross value add, comes from that particular sector. So they would say it's a vibrant sector, but it's now the 7th in the world on an illustrious list, falling behind the US, China, Japan, Germany, Italy and France, all of whom have, to Chi's point, some form of combined economic and industrial strategy which actually points to the importance of engineering and manufacturing. When the government talks about manufacturing, I would contend that it's actually talking about engineering and manufacturing, because simply to manufacture somebody else's stuff, somebody else's design, doesn't actually follow through the design intent and doesn't actually allow you to exploit the value of that intellectual property. So when I talk about manufacturing, I tend to think of it as starting with engineering, where engineers choose to manufacture to bring their product to market. So what can we do about it? Well, quite fundamentally, I think the UK has to play to its strengths. I think we have significant strengths in many sectors, in aerospace and defence, counter-cyber, automotive, evidence, Jaguar Landrover success, and also the Formula One success, in software, but also, of course, in pharmaceuticals and in other sectors, and possibly a growing sector in terms of green energy. We have to play to those strengths. The critical thing we can do, and going back to Chi's analogy of levers, is to address the skills issues. If we are to genuinely improve managerial quality in this country, to make the best of our innovations, if we're to have the skills necessary to create the products and sell those products, the key investment that we can make is the one in skills. It is within our gift to do that, within industry and business and within government to make that happen. But as a leadership community, it's up to us to make sure we meet the skills agenda. And no doubt we can continue to talk about that as the morning goes on. Thank you.
Good. Thank you very much.
Well, good morning, and thank you for the opportunity to speak to you this morning. I was thinking about what is it that makes engineering unique. And for me, it's one thing. Engineering turns ideas into useful, wealth-creating products, jobs and services, whilst at the same time tackling some of the great challenges that Sir John mentioned. And for me, it's this twofold nature of engineering which is unique to it, and which makes it very special. It addresses some of mankind's greatest issues, and at the same time makes money in the near term. Now, there are many examples of highly lucrative things which don't generate any long-term good for society, and many people would say the problems in the city have been a manifestation of that recently. Similarly, there are many examples of socially useful activities which don't generate wealth. I mean, large spending on social services and healthcare are clearly of enormous social value, but they don't generate wealth in themselves. Without the flow of wealth-generating ideas, long-term investment in socially useful things cannot be sustained. Now, for me, the engineering discipline is almost unique in that it can generate wealth and be socially useful. So, how do I think we're doing in this important area? Well, pretty well in some areas. I feel our good universities are amongst the best in the world, and they provide a great R&D foundation. Recently, we've been doing some work on company taxation, and I applaud the move to putting R&D credits above the line in the accounting. That will be very beneficial for companies that do a lot of R&D. And similarly, the proposed patent box legislation will also be useful in encouraging high-tech businesses. She mentioned the important role of government procurement, and I think here we do quite well. I think we have to accept that there will always be more money spent in procurement by government than there will be directly on R&D, so we should make the best of it. There's some good examples. Thermonuclear fusion, for example, holds out the opportunity for large amounts of carbon-free energy with very little long-term radioactive waste. The international collaboration on the ITER project provides a mechanism for scientists around the world to get together. It also provides a mechanism for companies like Oxford Instruments to provide real high-tech jobs in the UK in the near term. Socially important and financially gearing. So, some good examples, but I have to say overall I don't think we're winning the battle to be a high-tech economy. Why do I say that? Well, you're probably aware of the Lisbon target, whereby the UK has committed to increasing its fraction of GDP that it spends on R&D by 0.5%. Now, I'm not sure if we're going to make it. Interestingly, China has also committed to increasing its fraction of R&D by 0.5%, but it's going to do it 3 years earlier. From where I'm standing, a 0.5% increase in spending, 0.5% of Chinese GDP is a whole lot more interesting than 0.5% of UK GDP, which it turns out may not happen. You may have heard of the theme that's developing recently. The return of the sea turtles is a subject that's discussed much at Oxford Instruments. This is the policy of the Chinese government to encourage expatriate Chinese academics to return to China to continue their studies. The Chinese government is putting forward very large bursaries to enable them to set up laboratories of equivalent standards to those which they enjoyed in the West. Now, for Oxford Instruments, this is great because we get to sell a whole series of high-technology, world-class laboratories all over again. But if I was looking after UK PLC, I would be distinctly worried. Oxford Instruments is a high-technology capital goods business, and we sell into two principal markets: research, in academic and government-funded, and industry for advanced manufacturing. For this reason, our sales map corresponds very closely to where in the world GDP is growing. Where research happens and where the advanced factories are built is clearly where GDP is going to grow. Our turnover to the UK is less than 5%. And each year it drops as a fraction of the overall turnover. Conversely, my sales to China grew by 70% last year. Let me give you an illustration as to why I think maybe we've gone astray in the UK. Everyone seems to have a France story. I have my own one. We have a bit of cultural myopia as regards engineering in the UK, in my view. A few years ago, I was working in a company which actually is now part of BAE Systems. We were involved in a merger. My business was merged with our French counterparts. In the inevitable squabble for jobs, the French head got to run the business. He became the managing director, and he was a very good guy. And I got to be the technical director of the combined business. Now, what is culturally interesting is the attitude that people had to those appointments. In the UK, I was commiserated for missing out on the top job, given a pat on the back. Never mind, Jonathan, it'll be all right in the long term. When I visited France, I was lauded as having got the top job, slightly annoyed that the French had only got the administrative job and the real engineering job had gone to a Brit. But I thought that was very illustrative of the different cultural values to which we attach to engineering. I think the UK lacks a vision for a technology-driven future. It's not embedded in our culture anymore. I recently visited Taiwan. In Taiwan, the government is funding every technical secondary school to buy an electron microscope. That level of investment is absolutely stunning. They regard nanotechnology as a key skill which every high school graduate needs to understand. I think if you ask a man in the street what was nanotechnology important to the future in the UK, you'd get a vague look or some response about grey goo. We're just not really playing even on the same field. So overall, I think we tend not to value engineering in the UK. Service industries are important, but their foundations are always in manufacturing. If manufacturing goes away, the service industries will surely eventually follow. I believe the case for engineering is self-evident to anyone who thinks about it. However, unless we establish the economic, cultural, and social preconditions for a sound engineering culture, the UK will lose out in the competition for capital and skills needed to sustain a long-term, high-tech, engineering-led economy. Thank you.
Thank you very much.
So we've heard some very interesting views about the economic, social, and cultural aspects of driving growth in engineering in the UK. And as a lawyer, I just wanted to say a few words about why I think we need some sensible laws to drive growth in the UK, and just wanted to give some examples of some laws where there's some changes on the horizon, some areas we're doing well in, and some areas we're not doing so well in. Just to put that into context, I'm a lawyer. I work with lots of technology and engineering businesses, so I see firsthand which laws actually do drive economic growth and which laws result in success and which laws hinder success and growth. So I'll give a few examples of those. I also work with a lot of international businesses who are looking to expand beyond their markets, usually the US. I just happen to travel in the US a lot and work there, but it's just an example of a big market of successful engineering and technology businesses who are expanding beyond their domestic markets into Europe and beyond. And the reason for saying that is they have choices of where they want to expand to. Part of my job is to convince them to come to the UK. There's some self-interest involved. That way they instruct me, and I can continue to fund my son's mobile phone bill. But so I'd rather they expanded into the UK than Germany, than Ireland, or further afield. And they do have choices, and I can see what's attractive about the UK, what's working and what isn't. So I'll give a few examples of that. So I'll just start with a few macro examples on that second point. So, what do I tell a US businessman who's thinking about expanding into Europe? Why the UK? Well, truthfully, it's quick and easy to set up here. That's good. You can set up a company here in a day. That drives innovation into Europe. It drives investment. Those companies grow and eventually acquire businesses in the UK, and that all drives the cycle. We've generally got sensible laws. Actually, I'll give some examples where we're going wrong, but generally we're pretty good. We're pretty business-friendly compared to other parts of Europe. I mean, we've talked about France, and everyone's got a France story. I was an in-house lawyer for 2 years, and I covered, I think, 8 countries, and I had teams in 8 countries. I spent more than 50% of my time dealing with HR issues in France. So, other countries have their own problems. We don't. On that point, we generally have business-friendly employment laws, which, again, drives growth. So we have generally strong IP laws, and I'll talk about those in a moment. We've just commissioned, Taylor Wessing, we've just commissioned our 3rd annual Global Intellectual Property Index. It's an international survey. It covers 168 countries, takes over 1,000 survey views from businesses all over the world, and the UK consistently ranks highly in terms of protecting IP, but we could do better, and I'll talk about that. We have a lowish corporate tax rate. We talked about that earlier. We're not the lowest. We consistently lose out to Ireland when it comes to global businesses choosing where to headquarter. But, Ireland's one country. We're pretty good compared to the other large nations. So those are the good things. What are the bad things about the UK? Well, one of the negatives is the immigration laws. It's difficult for businesses to get their people over here and to establish quickly and cheaply. It's very easy for them to fall into bear traps and get it wrong, and that does put businesses off. That used to be easier, and that could change. Our personal tax rates are currently perceived as being high compared to other developed nations. I mentioned Ireland corporate tax rates. They're low, but they could be lower, although they are coming down. Our copyright laws in technology, maybe not so relevant for engineering, and I'll talk about patents where I think it's more relevant, but our copyright laws need an overhaul. They drive technology, and I know technology is relevant to engineering companies' ability to manage costs, innovate and grow. And libel. We have very claimant-friendly libel laws, which, as we all probably know, in recent years has had somewhat of a sort of stifling effect, or could have had a stifling effect, on scientific and engineering debate, and I'll talk about that. Lastly, one of the problems the UK has from an international perspective is that we're part of the EU, and I don't mean that in a political or economical sense. I mean that in a legal sense. We have a patchwork of laws, 27 member states, 27 different laws, and that is difficult for a US or a Chinese or a Japanese business to navigate. We're supposed to have harmonised laws, and we don't. We're getting there, but we're a long way off. So what do we need? We need harmonisation across Europe. We need sensible laws across Europe, not just the UK, because that will support the UK. We need single IP rights, and I'll talk about those, and single courts, I'll also talk about that. So just moving into a few specific examples. So I mentioned libel, and I just wanted to talk briefly about that, because I think it's very relevant to the scientific and engineering community and the ability to have free speech, free debate, and peer-to-peer reviews. The UK is regarded as the most claimant-friendly jurisdiction in the world. It's quite easy to sue someone for libel over here. You don't have to prove specific damage. You can get a lawyer who'll do it on a no-win, no-fee. So you can go out there tomorrow and sue someone for libel. It's quite easy to do. Therefore, it's not great if you want to exercise free speech and express your opinion. And the case I just wanted to touch on, we may be aware of it, was the Simon Singh case. As we know, Simon Singh published an article in the Guardian's comment and debate page, and I'll read it out. It's just a paragraph. And this was about the British Chiropractor Association. He says, the BCA claims that their members can help treat children with colics, sleeping and feeding problems, ear infections, asthma and prolonged crying, even though there is not a jot of evidence. This organisation is the respectable face of the chiropractic profession, and yet it happily promotes bogus treatments. I can confidently label these treatments as bogus because I've co-authored a book about alternative medicine with the world's first professor of complementary medicine. Among other projects, he examined the evidence from 70 trials exploring the benefits of chiropractic therapy in conditions unrelated to the back. He found no evidence to suggest that chiropractors could treat any such conditions. Okay, it's not about engineering, but it could have been. Now, the BCA sued him and won. He faced a huge legal bill, could have bankrupted him. Luckily, he had sufficient backers to appeal the case and appealed it to the Court of Appeal. And, you know, this wasn't one of those decisions that all the lawyers knew was going to go the way it did. He won, and it was a bit of a surprise that he won. And he won on the basis that what he'd said was opinion, which was based on evidence that he'd referred to. And I think that's absolutely right. And that's the way that scientific debate and engineering debate should go. And the court finished by saying, scientific controversies must be settled by the methods of science rather than by the methods of litigation. More papers, more discussion, better data and more satisfactory models, not larger awards of damages, mark the path towards understanding of the world around us. I totally agree with that. But that's not legislation. That was a case, and it turned on its facts. That needs to become legislation. And we have a draft defamation bill, which is currently going through consultation, that is looking to I suppose, adjust the libel laws in this country. So it's much harder to sue someone for trivial comment or for comment that is clearly an opinion based on expression. And that's going through the consultation process at the moment. It was introduced last year, and I really hope that that'll result in some more freedom of expression friendly libel laws. The next thing I wanted to talk about was just in the realm of IP rights. I mean, clearly, it's fundamental that anybody that wants to innovate is able to protect their innovation and stop other people from copying it who've not invested the R&D. That's why we need IP rights. In engineering, the most relevant right is usually the patent. So I just wanted to talk about what's going on in patent law in the UK briefly. At the moment, you can file for a UK patent, you can enforce that and litigate it. It's quite expensive to do it. You can file for a European patent, but all a European patent is really a bundle of separate rights. If you cover the whole of Europe, you're actually talking about 27 separate patents. Now, I don't know if anyone in the room has ever instructed a lawyer to sue someone, or let alone instructed as a lawyer to sue someone to enforce a patent or an IP right. But just imagine, I mean, that's expensive, time-consuming, stressful, all the things that go with it. But imagine doing that in 27 countries all at the same time. That's what you have to do if you want to have a European patent at the moment. That only protects big business. It protects those businesses who are able to invest millions of pounds in patent portfolios and lawyers to enforce those patents. It's not a level playing field. So that needs to change. Luckily, it is changing, but it's glacial in terms of the speed it's changing. We have a proposal that came, I think, 10 years ago. It was, actually 12 years ago, 2000, for a unitary patent which will cover the whole of Europe. That will have a clear set of rules, a clear set of fees, an accelerated timeline, reduced costs, and only a number of courts, but ultimately one central court. And that's something that I think the engineering community will welcome. It will drive innovation because it'll, I think, reset the playing field to a more level surface. Sure, sorry. Just finally, we mentioned the patent box. Certainly some welcome changes on tax, which are going to help drive innovation and allow the claiming of a 10% tax rate on R&D for patents. But it's disappointing that it's taking 4 years to introduce that. And finally, the Hargreaves Review is looking at IP laws generally in the UK. The key thing here is, unless a law is changed, it stays the same. It's still on the statute books in the UK, I gather, that every man in England has to practice archery for 2 hours a week. Now, unless that law is changed, that will stay on the statute books. These IP laws were created 300 years ago, and they need an overhaul. So that's all I'll say, because I need to go and practice my archery now. Thank you.
Good morning. I'm Bob Joyce, Group Engineering Director for Jaguar Landrover. I am a practicing engineer, was trained as one, always been one. I've been encouraged occasionally to do other things, and fortunately I've stayed on the path. I don't do plumbing and I don't do electricians. I pay tradesmen to do that job, and my wife is very glad about that, because when I do plumbing and electricians, I'm not very good at it. I'm here to talk about Jaguar Landrover. Pleasure here today. I just want to give you a little background on Jaguar Landrover. We are seen to be one of the success stories at the moment in the UK, and then give you two little case studies, one product and one process. Jaguar Landrover is the largest manufacturer of premium vehicles in the UK. We run 2 state-of-the-art factories, engineering functions, and 3 state-of-the-art manufacturing factories in the UK. We also just announced an engine manufacturing plant on the M54. In 2011, it was been a landmark year for us. We increased investment, we created jobs, we launched some breakthrough products, and we did all this on the back of sustained and growing profits. That is vitally important for us as we go forward. We must not forget that engineering has to be done within a profitable, sustainable business. We recruited more than 3,000 people in 2011, and as this is Apprentice Week, we're glad to support the Advanced Apprentice Higher Apprentice Scheme that was announced this week, and we are very pleased to take on people with A-levels and help them advance to a degree. In total, we employ 19,000 people in the UK and another 1,000 around the world. We support about 140,000 jobs, taking into account employees in the supply chain, dealer network, and wider economy. And as people previously have said, we sell our products too in the global marketplace. That's not just in the established markets of Europe and US, but we grow rapidly in China, Brazil, emerging economies, India. We are increasing our investment in innovation. We announced a new business strategy last year, increasing our investment in growth. We're investing over £1.5 billion a year on product creation. That's the research and development and capital investment, putting JLR at the centre of the UK's auto industry investment in the UK. We are the largest automotive investor in R&D in the UK, and we're probably the largest in the manufacturing sector. We've recruited over 1,000 engineers last year, as well as graduates and apprentices. Our research and development function launched typically at any one time 40 new product development programs over the next 5 years, and we, like British Aerospace, file over 100 patents a year. Let me now just take you 2 little case studies. First of all, the product. Last year, I think you've all seen, hopefully, the Range Rover Evoque. We launched that product. It was part of our design and innovation strategy. It is by far the smallest Range Rover product ever launched. A lot of product innovation in it. It has grown the volume. It has been a complete success for our business We've had to increase capacity. It has won over 78 awards since we've launched it, and was very pleasing just 2 weeks ago at the Detroit Auto Show that it won Truck of the Year in the home base of North America. Felt particularly good when we used to be part of Ford Motor Company. It lives on striking design, creative and high innovative product, bundled together with a manufacturing capability can produce a cost-effective business equation. It's a growth business for us and has attracted customers worldwide. It is class-leading sustainability. It's less than 130 grams CO2. And basically, this product in its own has caused 3,000 people to gain their direct employment. So again, taking our normal leverage, that's about 20,000 people here in the UK are currently living and working based off this product success. It was an incremental product to Jaguar Land Rover. So without doubt, products successfully delivered, exploiting innovation, exploiting what the UK is good at, can drive growth. Second example is about skills. About 4 years ago, we sat with all the engineering functional chiefs, and we discussed what was missing as we go forward. And we talk often about graduates and universities and skills, but the real challenge we faced was we have 3,500 engineers back at that time who were 30, who were 40 years old. They were with us for another 10, 20, 30 years. And the world of cars has changed. We had more people working on the infotainment system on the Jaguar launched a year and a half ago than on the whole car. We had 600 software engineers all working together globally on the infotainment system. Now, if I said that 15 years ago, and they'd have said, well, you just buy a radio and you fit it, don't you? And it's sort of, yeah. The world's changed. So we sat down and said, well, we need to upskill. So we looked at the courses. We came up with 30 key modules. We recognized that to drive that. We then said, well, what's the incentive for our employees? Because we couldn't afford to keep sending people on master's degrees, 1, 2, 10, 20, 30 people. It takes too long, and actually they were getting skills that weren't relevant to their job. So working with 4 universities, we actually agreed that they would pilot these courses. We also agree with them that the accreditation points would be consistent across these courses. So as the engineers go through their career, they can take courses in different universities and build up points towards a master's degrees or a PhD. It's a very flexible scheme. We launched it last year, a year and a half ago, academic year. We've already had nearly 1,000 people go on it. We think it's highly beneficial to the individuals. It's very cost effective. It leverages the key universities, often the key research partners for ourselves. And it's great for the individuals because they can do effectively continued professional development training, not just with our people. They'll do it with people from British Aerospace, Rolls-Royce, for example, on computer FCFD. They will share with like-minded skilled functions. And I'm very pleased to say that we're pushing the government to look at spreading this across our supplier base, because it's vitally important that our supply base in the UK can support such an initiative. And we're working with agencies such as SEMTA to put bids in to say, let's take this forward. We will support that. Clearly, our job isn't to develop these courses in that supply base, but we're very, very keen to see the benefits of that doing. So I think 2 very clear examples of how product and skills together can lead to a successful business equation. In summary, we think we're on a very good plan. It's actually quite a simple equation, but there is no silver bullet. But we are very, very keen to be part of a conversation that has a much more joined up government, university, and agencies and professional agencies to really address the key issues that many of my colleagues here on the panel today have highlighted that just need to be more integrated if we are to compete on the global stage. Thank you.
Manufacturing is hugely important to us, and I'm sure we're all very passionate about it. But of course it is a shrinking contributor to our economy, and that's what we have to do something about. And you'll have heard a lot from the government about the vital 6%. The 6% of companies, the 6% of innovative companies that have driven 54% of employment growth in recent years. And I would like to say, that's great, those are all manufacturing and engineering companies. But actually they're not. They're a very diverse mixture of sectors and a very diverse mixture of sizes. And of course, we do have some of them here. We've got Jaguar Landrover, we've got BAE Systems, we've got some of the people who are in that 6%, but we don't dominate it, and we could. And I think one of our big challenges is, how do we get more manufacturing and engineering companies into this group, and how do we make it much bigger than 6%? Because much bigger than 6% will drive much more employment growth. Well, the characteristics of those companies are that they invest in R&D, they employ high proportions of graduates, they engage in exporting, and they innovate in terms of products, services, and processes. Well, the R bit is easy. The UK is world-leading at R&D, and we should be really proud of that. We're second only to the US on the number of citations of our scientific work, but if we had a population equivalent to the US, we would be generating 55% of global citations. The US currently generates only 41% of global citations. And if we look at citations per pound, an interesting idea. You go into a shop and ask for a bag of pounds worth of citations. Anyway, at citations per pound, we generate 3 times as many as the US. So we have phenomenally cost-effective R&D in this country. So one of the things we must do is ensure business can and does engage with research in the research base, and that also that business, as John has said to us, that business engages strongly and has a stronger role in shaping that research agenda. And we need to ensure that things like the Technology Strategy Board, the research councils, maybe even the LEPs, engage with business and our universities to help take that forward. In terms of graduates, we still have a university system, despite all the things going on, that is the envy of the world, and we still get more overseas students coming into that system than any other country but the United States. Our universities are increasingly focusing on things like employability and internationalisation of our graduates. And if I can do my bit of advertising, I'm afraid, at Aston, we have over 60% of our students take a placement year in business and industry as part of their degree. We're increasingly making sure they can get overseas placements. We have a target to get 75% of our first-year students taking a foreign language as part of their course. We have all sorts of innovation and entrepreneurship societies, guest lectures, challenges and competitions. We're trying to make sure we are generating the graduates that industry need, but like all of our colleagues in the university sector, we would welcome increasing engagement to help make sure we're delivering the graduates that are needed. But actually, we have great engagements with companies like BAE Systems, Rolls-Royce, Jaguar, Landrover. The big challenge is to get these graduates, these innovative and internationally oriented graduates, into smaller companies, into the supply chain companies, into the companies who are not yet in that vital 6% of rapidly growing companies. So let me come back to that later. On innovation, the UK leads in some areas, although actually we should be careful because in all the current innovation rankings, we are ranked next to Norway. And in some of them, Norway is ranked ahead of us these days, so we should be a little careful about. But one of the things the UK still has an exciting, I think, leadership role in is in this area of business process innovation, one which is very closely involves our engineers. And I want to mention just one aspect of that, which is something that my team at Aston do a lot of research on, run by Professor Tim Baines, but that's servitization. And that's very close to my own heart, having worked at Rolls-Royce for many years and experienced personally the impact that's had on the company performance and the share price. Put simplistically, at Rolls-Royce, we used to sell engines at a loss, wait 15 years, and get the spares revenue. We annoyed our customers because when things started going wrong, their costs suddenly shot up. They now sell power by the hour with an immediate return on investment, with an income through the life of the expensive product that they're supplying, and the customers get costs that they can plan and are not suddenly hit when, for example, a series of combustor failures happens. So it's a sharing of risk, but it's been absolutely win-win. So moving to a focus on outcomes from the product in use, not simply this focus on sale and delivery. So it has huge benefits, it has huge potential, and it has a huge impact on the supply chain, because the supply chain now needs to be thinking about how do they provide services to the OEM rather than simply parts. Servitization can drive all sorts of benefits for the UK. It can drive localization and integration with the supply chain. That's going to be very good for the UK if Jaguar, Landrover, Rolls-Royce, BAE Systems, JCB, if all of these companies drive up innovation in their supply chains in the UK. And part of that comes through apprenticeships. And I hope everybody is engaging in Apprenticeship Week. OEMs can lead on the skills and thinking that is needed in graduate and technician apprentices for this new era of servitization. OEMs need to be taking on large numbers of those so that they can be spread out into the supply chain and raise the capability of those companies. OEMs have the brand names to attract the apprentices. My students are queuing up to go and work for Jaguar Land Rover. They probably couldn't name a body-in-white company. So Jaguar Land Rover is a brand that we can really enthuse our young people about. We need schemes that help OEMs to do the graduate apprentice and the technician apprentice training to get the thinking and the skills out there into their supply chains. And one of the things the government actually has announced is a new apprenticeship scheme that business can apply for the funding for. And I hope the OEMs will respond very strongly to that, because it is a way of starting to get this flow down. Servitization improves the product engineering and the sustainability, because it gives you that direct link to the product in use to the designer. That link that when you sold the product and it belonged to somebody else was broken and you had to scrabble around to find out how well your product was performing. That direct feedback gives us a chance to really make sure our products are world class. It changes, as I've said, the risk and reward sharing. It's the kind of business process engineering that we are going to need to help us to introduce the new green technologies that are called for by meeting the challenges of climate change, and indeed in the UK by our Climate Change Act. I might pay for miles driven rather than buy an expensive electric car. I might pay for a refrigeration service. There are really exciting opportunities here, which, if we can make them happen, will make us more competitive in the UK. So let me finish by saying, despite the rumours that great R&D and UK universities are in decline, actually the evidence says they are still very, very robust and maintaining a leading position. And we are doing a lot to work more closely with business, but our doors are open, so please do come in through them and help us to do that even better and to generate even more relevant research and employable and international graduates. The UK is well placed to build an internationally leading capability in servitization, driving up the proportion of that vital 6% that are manufacturing companies, but actually driving up that 6% figure to make it 50% of UK companies that are really driving growth in this company. Servitization can unlock the green economy and really help us drive economic growth. And finally, as Sir John was saying, we are really starting to get the message across to young people about the importance of engineering. University applications this year are down 8%. Engineering applications are only down 2%. And in many universities, including my own, engineering applications are up this year. So let me end on that extremely positive note. The Academy has been doing some very good work in helping get that message across. Thank you.
So we're opening the floor to questions. I think there are microphones around, so please, let's get going. Table 1 here.
Thank you. Barry Dennington.
If you could give your name and the company, it'd be great.
Yes, Barry Dennington, Plessey Semiconductors. We are an innovative company, 160 people, 50% of which are PhDs and engineering degree level. We've acquired 2 technologies from University of Sussex and University of Cambridge, disruptive technologies which will ramp up into production this year. And we're privately owned, private sector investors, management, and a small amount from Intel Capital. We're currently raising money to ramp up the manufacture, and it's very difficult to do that with government support. Most of the processes I'm coming across seem to take 8 to 12 months to get through application and due diligence, and even then the drawdown process is some time after that. I can go to China and I can get 5 to 10 million pounds within 8 weeks. How can we speed up government investment programs and plans to do this in weeks rather than months or longer than a year?
Something called bureaucracy in the way, is there? Who would like to tackle that?
Can I give it a go?
Yes, please.
I don't know if you can hear me. Microphone number 2. Let's give that a go. Can you hear me? Yes. I think the answer to your question, my answer isn't a specific one about the bureaucracy, but goes to the heart of the issue, which is that if you have no destination, then any route will do. And until the UK comes up with a combined industrial and economic policy that helps us all understand the framework that will allow us to win that economic battle in that global competition, then the answer is that nobody will actually understand the importance of that application and why it should be processed in 5 to 6 weeks. And perhaps I echo Chi's comments in her address, but those sorts of issues we will continue to trip over until we can get that combined economic and industrial policy up front and central. In the way we approach these things, that is the only way we're going to get to where we need to be.
Anyone else in the panel like to just reflect on that? Jonathan, would you?
I think the banks are very risk averse at the moment for understandable reasons, and I think maybe good investments are getting missed out along with some quite bad investments. And also, we may be bad in the UK, but you try and raise money from the European Investment Bank, which has taken 2 years to make a decision on something that I'm doing. If you were trying to launch a product in the space of weeks, it's absolute nonsense. The time scale is all wrong.
I think we're going to go through quite a difficult period with our banks until they actually get the capitalised base that will meet the new requirements. So the liquidity, there is a liquidity squeeze without a doubt, and we're going to have to go through that, I think. There's no easy route, I believe, to easing the lending for a bit, unless you had government actually stepping in. So I think, again, there is some pressures on to do that. Take another question, next table.
This is more of a plea rather than a question. Being Apprenticeship Week, and I apologise to anybody at the meeting yesterday, we need to seriously find out why small SMEs are not taking on apprentices. 83% of the company, I think it's 87% of manufacturing companies in the country do not take apprentices on, and this is going to hold back their growth of the economy.
That's a surprising figure, I have to say. 83%.
87%.
So it's very much reliance on the larger companies that are really driving the apprenticeship scheme. Is that the experience along the panel?
It is, yeah.
Absolutely.
Julie, have you a view on this from where you sit?
Yes, I mean, we do a lot of work in the university on trying to get SMEs to take on graduates, and also now with our university technical colleges addressing the apprenticeship agenda. But I think we really do need to see a kind of flow down into the supply chain from the OEMs, because actually they have the ability to do it at a very high quality level and to instill the thinking that the supply chain companies need. So support at that level to make a system work, I think, is really important.
So John, if I can add a comment, as well as my day job in BAE Systems, I'm also a commissioner in the UK Commission for Employment and Skills with specific responsibility for developing the vocational skills agenda in the UK. And during 2011, we hatched a plan to divert the government spend on vocational skills direct to employers. It's called the Employer Ownership Proposition, and it was announced by Vince Cable and Danny Alexander in the middle of December last year. It's a £250 million fund over 2 years for employers to propose how they aim to increase the vocational skills agenda, and in particular apprenticeships in the UK. And we will hit the hotspots there of developing apprenticeships within SMEs and in some of the regional hotspots around the UK. So the sentiment is understood, but we're now beginning to see some government money behind it, which is encouraging.
Well, that's helpful. I think I may say something that will upset some SMEs in the hall, but I think there's been a tremendous emphasis in words in government on the importance of SMEs, and SMEs are hugely important. But in my view, they've taken the focus of the large companies that actually are the traction engines that pull the supply chains through. And if you have healthy big companies, they will pull healthy supply chains through. And that's something that we're losing sight of, in my view. And we've got the emphasis wrong.
There's too much confidence. There's too much on the big companies. We're not looking at the small companies.
Yeah, but my point...
Massive growth from the small companies.
Yeah, I agree with that. But my point is that you need to take care of the big companies and have the industrial policy to allow them to perform, to pull through the supply chain, because most of the SMEs in this room feed off large companies. You disagree with that?
Yes.
Okay, that's good. I like a bit of controversy, especially in the mornings. Yeah. Just wait for the microphone, sir.
Colin Besant, Imperial College. I've worked most of my life with small companies, and I would agree with my colleague here on my right that, of course, you're right in saying we need strong big companies, but we've got too few of them in the UK.
Correct.
That's our problem.
Correct.
I've
Correct.
had to go overseas to get most of my investment.
Yep.
My latest company, heavy investment from a very large Brazilian company. We supply products to the United States, to the Air Force, to Boeing, and the rail industry. And I said we're exporting products. And we've been able to grow our workforce with this investment from 110 people up to 210 people just in this past year. And we're going to grow to over 300 people this year. Of course, it's hard to find skilled people because of the lack of apprentices, and also it is hard to find good graduates, and we've had to again attract a lot of people from overseas, and it's a real shame that we're not able to attract people from the UK.
And is your growth being driven by engineering innovation in your products, or
Absolutely.
how have you achieved it?
Yes, it's through innovation. These are high-speed electrical machines running on active magnetic bearings and the power electronic systems that goes with those machines.
Yep. Excellent. Tremendous. Well done.
Good morning. Chris Eady from the Welding Institute. I'm the Associate Director for Professional Affairs and Certification. Just to follow on the theme that's been started, I firmly believe that our solution to the skills gap will come from the SME cadre.
Yep.
And in that respect, we're attempting to set up a group training association for welding apprenticeships that will bring together large numbers of SME employers and give them the bargaining power with colleges that large enterprises have enjoyed. What would help us to do that is if the OEMs actually specify into their supply chains that their supply chains are also there to provide skills for the future, not just the widgets that go into manufacturing.
Yep.
I'd also like to offer to the panel and welcome their comments on how they might further use the facilities, products and services in the intermediate sector to support not just apprenticeships but education right the way through higher education institutions as well.
Bob, I think you've got to take this one.
Well, I think we've got, as I said, we've done a lot on continued professional development and expanding this master's module, these modules which are 1-2 week courses, into more universities, more subject areas, and then, as I say, we're actively looking at putting this out into our supply base, because I want my supply base to be good. I spend a lot of money. I spend nearly £200 million with my suppliers on engineering technology development. I need them to be competent. I can't afford to hire people from them and delude them of the skills. And I do recognise that. So I think the thing we're working with CEMTA is actually coordinating this in hubs. We start with automotive because it's sort of common. But I said a lot of these things go across. CFD is CFD. It makes no difference. Systems engineering is systems engineering. I think the more we got into this modular packages of high-end quality courses that are relevant to the manufacturers, including the small and medium enterprises, it's really useful. Because I think it then gives access, because I think when you're a small company, you can't afford to send somebody on a master's degree, but you can say, there's 2 weeks on, I don't know, advanced systems engineering, modelling or something. You go, that's a great course, and we should really work on that. Because that, I think, UK PLC is big enough to have the critical mass, it's got the academic skills, it just needs to be much more coordinated and get the universities to work together and industry to work together and just close the link, close the loop.
No, I think you said you had 19,000 employees, but 140,000 probably in the supply chain. I mean, we have too few companies like Jaguar in this country, to take the point made by someone. But BAE has, what's your supply chain like in the UK?
We have 7,500 companies in our supply chain, 2,500 of them are SMEs. We have a particular approach to managing our SMEs, which is to recognise that in defence contracting, cash flow is difficult to manage, so we work with the suppliers to make sure their businesses are sustainable. We have an innovation fund where we respect and understand that sometimes the innovation is best fostered within that SME environment, and in many cases we will fund that and allow the SMEs to keep the IP, but arrange how we actually access that. To be straightforward about it, my business is critically dependent on the performance of my supply chain. If any one element of that fails, I fail. So I've absolutely got to look after the supply chain. And that goes for the skills too. And to Richard's point earlier on from the audience, there is a big opportunity for the OEMs to actually start overtraining using their brand to attract people, but train for the supply chain in general. I think that's the way we've got to move.
Yep. Very good. Yes, sir.
My name is Chris Simpson. I'm representing the Institution of Mechanical Engineers this morning. Much of my career has been spent working in Germany, and I'd just very briefly like to pick out 2 of the points. One concerning apprentices. Could I quietly submit that one of the fundamental problems we have is that we pay apprentices too much? And by that I mean that an apprentice coming out of time will be earning something over 90% of a full-skilled rate. And I would just ask, from the perspective of an employer, and particularly an SME, is that individual worth almost the same as somebody with, let's say, 10 or 15 years experience? If you compare that with Germany, somebody coming out of a longer period of apprenticeship will be earning about 60% of the skilled rate. The other point concerning funding for manufacturing, I would submit that what is required is a fundamental restructuring. Most of the funding for small and medium-sized companies in Germany doesn't come from the larger banks, but from the local Sparkassen. And we are, in fact, my company is being commissioned at the moment to undertake a survey and see what the practical possibilities are of introducing a system like that into the UK, where you have local banks with local funding, but supported by national insurance facilities. So that means that funds are available at much more attractive rates, that there is a local connection with the local community.
Yep.
And when you reflect, I think, on the basis of the latest Bank of England figures, that our major banks are getting money at 0.5% and lending on at between 10 and 13%, that smacks more of usury than it does of providing credit. Thank you.
I think your point is very well made, but any comments? Jonathan, do you have a view on anything that's said here, given your European experience?
Well, a couple of points. I certainly am familiar with that German model of banks, and it's also quite prevalent in the US, surprisingly. You will get local banks, high technology businesses, who, when you say, where do you get your money from? Well, we go to the bank, and by that they mean the bank that is 3 doors down from their building. I'm quite surprised at how often I meet that. The other point, I guess, in looking at the German funding model, I do find German local government, the Länder governments, Länder in the German area, governments are very supportive to high-tech industry. when during the engineering downturn of 2009, I found the German government particularly helpful in paying for part-time work.
Yep.
We did not lose one single engineering head in Germany because of the very supportive culture provided by local government in Germany. That was not support that I enjoyed from the UK.
No. It was a very different industrial framework or strategy or whatever we would like to call it in Germany and indeed in many of our competing nations, and that's the very point that I certainly was trying to make at the beginning of the morning, and we've really got to push for that, and funding is just one dimension of that. There's no question that the banking system in Germany has a lot of local state support involved in it, and I'm not sure ever how the US system works, but that you refer to whether the state involvement there or not, but there seems to be something. Yeah. We'll have time for 2 more questions. Yes, we'll go to that table here, starboard side. And then the lady here.
Sorry. Chris Emsley, I'm the Chief Executive of Fibercore Limited, an innovative company that span out of the University of Southampton 30 years ago. I wanted to pick up on something that Bob Joyce said, referencing technical education. I was very interested when he suggested that traditional university courses were teaching skills that industry didn't need, and advocating much more of these shorter courses with a point system building up to master's and doctoral qualifications. What I would ask is, how do we actually square that far more structured approach to education with the fundamental need for innovation, which would tend to thrive more in less structured environments?
Okay, I think we'll ask Bob and then we'll ask Julia.
It's a really good question. My many years' experience in our business is we actually become schizophrenic. I as the leader of that business, sometimes often schizophrenic. On one hand, our success is based on disciplined, detailed engineering, structured process review. I can't afford my cars not to be safe. Yeah, so the detailed analytical, the program management are really complex, and that's where I need continued monitored professional development to get the real skill sets in those areas of these growth areas. Yeah. Having said that, I need another completely different group of people who are highly innovative. And people say, well, can't you be both? And you say, well, yes, but you can't be both at the same time, and you have to manage it in a different way. So we have a separate group with Warwick Manufacturing Group. We've got up to 200 people based there, a sort of innovation centre. We've got places around the world where we exploit, where we do really encourage using different tools. And there, I don't need them to go on these courses. It's useful if they go into delivery mode or they need these skills. In our business, 80% of the people in product development are in the delivery mode, and 10% are in the sort of creative, really up front. And we pull people in and out of that loop as they go through the process and have personal preference. So we need both. Yeah. We need a very broad technical training, but ongoing, the delivery side of our business, which drives sustained manufacturing, SMEs, big OEMs, you need a much better bench strength of competent engineers. And that's what we have to do.
I agree with that, but we still need to somehow strike a difficult balance with the true innovation.
I think we're pretty, my personal view is we're pretty good at innovation. My business's problem is actually ongoing. I had to train people in advanced control systems because nobody out in university did it. Nobody does CFD for automotive. You know, how do you apply it? And so you sort of go, I need these skills. They don't exist in the UK. They do exist in Europe.
Julia.
I mean, I think, not sure quite what we're sort of disagreeing about here, because Bob is saying, you know, he needs people who've got a very sound engineering training at university. He's not saying he wants people to collect their degrees a few points at a time. Because you know, you're not going to, in a business, in Rolls-Royce, we would say we need the university sector to train people in thermodynamics and fluid dynamics and things, because it's very hard to do that in a company environment. But when you then get to some of the specialist tools that we needed in Rolls-Royce, that Bob needs, it is appropriate that there are short courses out in the modular approaches that can add those on. But also, there's a lot of change going on in how we teach in universities, particularly in engineering, and moving it to a problem-solving approach where you don't throw all of the maths and complex techniques at them first. You get young engineers really engaged in the excitement of solving a problem and then realizing they've got to do some of this tough stuff to learn the tools that they need to apply to be able to get to the solution. And really motivating the learning experience and emphasizing actually what some of these more difficult techniques are for.
But I think it's interesting that you actually use...
Okay, we're going to move with, I think, this lady here, this table. That's the last question, and then I'm going to invite Dr. Stephen Garwood to the platform for a few minutes.
Thank you. My name's Catherine Coates. I'm the Director for Business Innovation at the Engineering and Physical Sciences Research Council. And several of the speakers have mentioned the excellence of UK university research, and several have talked about the connections that they've got with universities. So my question to the panel is what opportunities they see for engaging with universities and research in a more systematic way, and how have they gone about that, and what is their advice to other companies about how to do that in the most positive and structured way?
I think let me start with Bob on that, I think.
Okay, I think we spent a lot of time selecting the key universities for the key technology we want to develop, often whether it be on training courses, on recruiting key skills, or on doing research. Often it's two or three, all three together. And then what we've done is match them with some key senior champion sponsors so they get, I think we're not as advanced as the aerospace industry. British Aerospace and Rolls-Royce, I think, have been doing this systemically for many, many years. We're sort of a bit in catch-up. We're actually more reliant on the UK than we've had in our previous ownership experience with US company. But we've got to build those links at that senior sort of professor, vice president, at our engineering director level to really set out the agenda for each of these universities for recruitment, for training, for research projects, for partnership with SME companies. We've got some great links with small SMEs in this country. The Technology Strategy Board for Automotive, the NAIGT, has been really helpful in having an automotive view of how we integrate together. So with Nissan and Ford and other people in the UK, we sort of develop. I think that structure is in place. It now needs to sort of step up a gear and continue to develop.
I think, Julia, how are you perceiving industry's engagement with university? Has it increased in recent times?
I think it is increasing. I think the university sector sometimes feels a bit frustrated that industry thinks we don't engage with them enough. And I think we would say, look, our doors are open. Yeah. We sometimes don't actually know how to get in through your doors. Yep. So there are still some communication blocks. There are lots of great examples of the way big companies engage with universities. I think we do need more schemes to help smaller companies engage easily with universities, and it's good to see that the government is going to be making the Innovation Voucher Scheme a national scheme through the Technology Strategy Board, but I think the amount of funding in that is not going to go very far. And I think we will also see that some of the schemes like KTPs, the knowledge transfer partnerships things, are also very important, but are probably not going to have very much funding available in them for getting smaller companies sort of in through the doors of universities and engaging. But personally, somebody who's worked both in higher education and in industry, I still think, particularly in engineering and in business schools, we actually need more movement of people between companies and universities. Yeah. And sometimes things like the Research Excellence Framework can have quite a negative impact on that, because if people come into the university sector from industry, they don't have the publications and research background. But boy, do they have the understanding that we need to instill into teaching our students in these applied subjects.
Well, we clearly could go on here. It's been a very lively discussion. And again, thank you to the panel. I'm going to invite Dr. Stephen Garwood just to the platform for a few minutes to say a few words about the Industrial Systems report, which is being launched today.